Hello students, this is Guru from thetubeguru.com. Students, today we are going to start a very super important topic in the mathematics, that is number system. Students, this topic is so important that I can tell you that there is no mathematics without number system. It is so important, it is so crucial. So students, let's start with our topic, number system. Before we start with the number system and to its complex problems, we will going to understand some basic concepts, some basic things. And the most basic thing in number system is types of numbers. How many types of numbers are there? And the first type of number that we are going to study over here is natural number. So students, what is a natural number? Student, to get you a feel of natural number, I have invited some cows on my screen, as you can see. Now I have added a few cows over here. I need you to count these cows. So you can pause the video and you can count these cows, how many cows are there. So let's count it. This is cow number 1 and 2, 3, 4, 5, 6 and 7. There are total 7 cows on my screen. Okay, now have you noticed that you have started your counting from 1? And it's obvious, we always start our count from 1 only. What's there to observe, what's there to notice? But yes, we have studied from our from the day we were born that numbers start from 0, 0, 1, 2, 3, 4, and as we grew up we came to know that there are different type of numbers. Like there are some numbers which have negative sign in front of them, like -2, -5, -100 and so on. And there are some numbers which have decimal with them, like 1.5, like 3.7, like 5.2. And there are some other numbers also which are in fractions, say 1/2, 3/4. So we have studied so many kind of numbers, but still while counting we always start from 1. We start our counting from 1. We say 1, 2, 3, 4. We never start like 0, 1, 2, 3, or we never start like -1, -2, -3. Why? Because for counting purpose we always use natural numbers. Okay, so the use of natural numbers is for counting. That's why these natural numbers are also called counting numbers, natural numbers or counting numbers. Okay, now as we have seen that natural number always start from 1 and then they go on to infinity, 1, 2, 3, 4, 5, 6, and the number to the beyond, and then to that beyond also, and so on. That's called infinity. We don't know the end of natural number, so we write it down as this symbol, which is called infinity. So natural numbers are those numbers which are used for counting. They start from 1 and they go on to the infinity. So all the natural numbers in the world are denoted by a single alphabet called n. N is a set of all the natural number. N represents the set of all the natural number. For a reference, I have also written down that natural numbers contains only the numbers starting from 1 to infinity. It do not contain 0, it do not contain fractions, it do not contain negative numbers, it do not contain decimals either. So this was the story of natural number. Now I hope that you have understood what are natural numbers. As you will explore mathematics more and more, you'll get to see the use of natural number. Right now I'm not going to discuss the use of either type of the numbers. I'm going to explain you a lot of types of numbers, but I'm not going to explain you the use of those numbers in mathematics, because you are going to get confused over here, as you might not be knowing the theories and the very detailed things about anything. anything in mathematics, so it might confuse you. That's why I'm not going to discuss these topics in very depth. Okay, I'm just going to give you an overview. So I hope that you have understood what are natural number. So the next type of number that we are going to study here is whole number. Whole number. Now we have seen that natural number contains all the numbers starting from 1, 2, 3 to infinity. Now the whole number is a set of all the natural numbers plus 0 also. Okay, so what are whole numbers? Whole numbers are all the natural numbers, and in addition it has 0 also. Okay, and the whole number is represented by a set of W. Okay, W represents the set of all the whole numbers. Now here also there are no fractions, there are no negative numbers. Whole number contains all the positive numbers starting from 0 onwards. Okay, so the next type of number is integers. See, we have seen that there are natural numbers starting 1, 2, 3, 4 and so on till infinity. And then we have a whole number in which we have a 0. Okay, and all the natural numbers. Now if before 0 we add all the natural numbers with the negative sign in front of them, then it becomes an integer, a set of integer. It's like -1, -2, -3 and so on till negative of infinity. Like there's a positive of infinity, the similar way we have a negative of infinity also. All these numbers are called integers. Okay, and they're denoted by Z. They are denoted by the set of all the integers. All the negative number 0 and a positive number is denoted by Z. Still you can see that integers do not contain fractions. Numbers like 2 by 3, 4 by 3, 1 by 2, these numbers are still not calculated in integers, counted in integers. Integer is a number without a fraction, without a decimal. It is just a simple plain number with a negative sign or a positive sign. So students, the next type of number that I'm going to discuss with you is rational numbers. Till now we have studied natural number, whole number and integers. Okay, we haven't seen anywhere that what kind of number is 1 by 2, or what kind of number is 3 by 4, or what kind of number is -5 by 4. We haven't seen till now that what kind of numbers are these. These are fractions. These are the numbers in fractions. So what kind of numbers are these? These are not integers. We have seen in integers that the numbers are not in fractions. We have also seen in natural number as well as whole number that numbers are not in fraction. So all the numbers that are in fractions are called rational numbers. Okay, so we can generally say that all the numbers that are in form of P upon Q, all the numbers that are in form of P upon Q are rational numbers. Okay, so here you can see that the value of P is 1 and the value of Q is 2, as P is in numerator and here also 1 is in numerator. So the value of P is 1 and the value of Q is 2. If we take this case, then here the value of P is 3, the value of Q is 4. Here the value of P is -5, the value of Q is 4. So you can place any integer at the place of P, and you can place any integer at the place of Q. It becomes a rational number. Suppose we put the value of P is say -100 and we put value of Q as 2 or say 3, then -100 by 3, this is another rational number. I hope you are getting my point. Here P and Q both are integers. Okay, but a point to be remembered, a point to be noted over here is that suppose the value of P is say I put it 5, and the value of Q, say if I put value of Q as 0, then we know that something divided by 0 is not defined. Okay, so if something is not defined, then how can it be a number? It means the value of q can never be equal to 0. If the value of q becomes equal to 0, then the number becomes undefined. Therefore, it's not any kind of number. Okay, so here p by q, in this case we have p can be any integer and q can also be any integer except 0. Okay, it's clear. So value of p can be any integer and the value of q cannot be equal to 0. Now till all the numbers, we have studied 4 kind of numbers till now, and the rational numbers are one of the most important type of numbers till now. Okay, and for the rest of the chapters also. And before we proceed with the types of numbers, first I wish to discuss more about rational numbers. We are going to solve some type of problems on rational numbers, then we are going to move ahead. Okay, now students, there is one more important thing that I wish to discuss over here. We have seen that we have p by q. Any number which is represented in form of p by q is a rational number. Okay, now suppose the value of p is 5 and the value of q is, say, it's 1. Then what is 5 by 1? It is 5 only. Okay, and what is 5? 5 is an integer. Okay, fine. Now suppose the value of p is 4 and the value of q is again 1. So we again get 4. If the value of p is, say, minus 100 and the value of q is 1, then we get what? Minus 100. Okay, so we can see that if the value of q is equal to 1, then the rational number becomes an integer. It means we can represent rational numbers in form of integers also. Okay, and we can represent any integer in form of rational number also. Like suppose you are given an integer, say minus 3, and now you have to represent this number in form of rational number. So what you'll do, you will just divide it by 1. Okay, so what is this? This is in form of p by q, therefore it is a rational number. Okay, so we can say that all the integers are rational numbers, but all the rational numbers are not integers. You can convert all these integers in rational number by just dividing them by 1. Okay, so each and every number written over here will become a rational number, but you cannot convert all the rational numbers into integer. Suppose you have a rational number, say 5 by 3. Now you cannot convert this number into an integer. You cannot represent this rational number as an integer, but you can represent any number, any rational number that is having 1 in the denominator as an integer. So we can clearly see all the integers can be represented in rational number, but all the rational numbers cannot be represented as integers. Now these were some very basic, very important things related to rational numbers and the other types of numbers. Now let's start problem solving with rational numbers. Now here's one of the most important type of question that you are going to study in rational numbers. We are here asked to insert a rational number between two rational numbers. Okay, here is the question. We are given that insert one rational number. We have to insert one rational number between 1 by 5 and 7 by 5. We are giving two rational numbers, 1 by 5 and 7 by 5, and we are asked to insert one more rational number between them. So how do we solve these type of problems? See, here you can clearly see that in both the rational numbers we have denominator as same. In both the numbers we have 5 as the denominator. So the step 1 is make denominator of both the rational numbers same. But in this case, luckily, we have both the denominators as same only. Okay. Now the step 2 will be find the numbers between numerators. Here in numerator we have 1 and in another numerator we have 7. We have 1 and we have a 7. And in denominator we have 5 and 5. Okay. Now we have to find only one rational number. We have to insert only one rational number in between these two numbers. Okay. The first step we have done, that denominator should be same, and the second step is that in numerator, which is 1 and 7, insert any number between 1 and 7. Insert any number between 1 and 7. So just name any number between 1 and 7. Say 6. Okay, 6 is a number between numerator 1 and 7, and place a denominator also, which is 5. In both the cases we have 5, so we will place 5 over here also. So 6 by 5 is a rational number which lies between 1 by 5 and 7 by 5. Somewhere in between 1 by 5 and 7 by 5. And likewise we can add any number of integers, so any number of rational numbers we want. Say 2 by 5. 2 is a number which is between 1 and 7. So 2 by 5 is also a rational number between 1 by 5 and 7 by 5. Similarly, 3 by 5. 3 is a number which is between 1 and 7. So 3 by 5 is a rational number which lies between 1 by 5 and 7 by 5. Okay. Similarly, 4 by 5. 4 is a number that lies between 1 and 7. So 4 by 5 is a rational number that lies between 1 by 5 and 7 by 5. So we have to follow these two simple steps to insert any number of rational numbers between two rational numbers. As we will solve 2-3 more problems, then you'll get a better understanding of what how we solve these kind of problems.